Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 8, 2025, about 6 days ago. This paper introduces a reproducible, Oracle-free benchmark for repository-level performance optimization and finds that state-of-the-art agents achieve less than 0.15 times the expert speedup. The paper is titled, SWE-fficiency. Can language models optimize real-world repositories on real workloads? And, as we will see later, the gap it exposes points to important next steps for long-horizon software reasoning. Alright, the introduction set the stakes around real performance work. Figure 1 illustrates the full workflow. An agent receives a concrete workload and the entire codebase, then proposes an edit. The left panel provides the workload and repository context, which forces the agent to localize bottlenecks. The center panel shows the generated edit that must keep semantics intact because unit tests remain the guardrail. The right panels confirm both correctness and the payoff, reporting a speedup of about 1.8 times. So while the previous figure framed the end-to-end task, Figure 2 shows the 5-stage pipeline that builds each benchmark instance. The process starts by scraping pull requests from 9 popular repositories. An attribute filter keeps only edits with performance keywords, no test changes, and meaningful code changes. A coverage filter ensures unit tests exercise the edited lines, then workloads are manually annotated. Finally, an execution filter enforces passing tests and a significant reproducible speedup. Okay. Figure 2 outlined the data pipeline, and Table 1 contrasts related benchmarks. The table shows that only this benchmark simultaneously evaluates runtime, operates at repository level, checks correctness with the repository's own tests, and uses a separate end-to-end performance workload. Competing suites miss at least one of these dimensions. The final column highlights scale, with 498 optimization tasks. Well, Table 1 contrasted related efforts. Figure 3 presents dataset distributions that matter for realism. The left panel shows workload runtimes spanning microseconds to hundreds of seconds, with purple bars shrinking after the expert patch, which signals real speed gains. The middle panel plots speedup factors, concentrated near 1 to 10, but with a long tail. The right panel lists edit types, led by simplify code and algorithmic change. Alright, Figure 3 highlighted the dataset shape. Table 2 reports speedup ratio results, where 1.0 means expert parity and higher is better. GPT-5 leads at about 0.15 times, while most systems cluster near 0.01, which shows a large shortfall. The spread indicates that current agents rarely approach expert gains, so real repository optimization remains very challenging. So Table 2 reported speedup ratios that fell well short of expert parity. Figure 6 shows that models miss most expert achievable gains because they edit the wrong places, with about 69 to 75% of speedup left on the table across Claude 3.7 Sonnet, GPT-5 Mini, Gemini 2.5 Flash, and DeepSeek v3.1. The stacked bars split misses into wrong file versus wrong function within the right file. That split matters, since function-level mistakes dominate several systems. Wrapping up, 2 takeaways stand out. Current agents reach under 0.15 times expert speedup and often fail tests, so real repository optimization remains a long way off. The broader implication is clear. Progress needs stronger bottleneck localization, reasoning across functions, and correctness-preserving edits tied to real workloads. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.